Someone asked me how to do multiple ADC conversions at the same time on Hercules Launchpad, and the easiest example that I have is a project that I'm working on with the Hercules Launchpad and the educational booster pack here, where I'm trying to talk to the LCD, but I'm also listening to the joystick. In that example, I'm capturing both the X and the Y axis at a single shot, so let's see how that is working. This is the sample project. I am showing a menu on the LCD screen here, and I'm using the joystick to navigate through the menu and select options by pushing it right. All of that is just using two ADC channels, one to collect the position of the X and the other is the position of the Y. I call a conversion cycle and capture both values in the ADC buffer. Let's have a look at the configuration and at the firmware. This is going to be a very brief video because it's such a nice weather in Brussels and my plan is to go out. When we look at the booster pack overview, this part defines the joystick functionality. So we have movement in the X and in the Y axis, and the X axis is broken out to jumper 1 pin 2 and the vertical one to connector 3 pin 26. On the connectors you can see that here this is the joystick horizontal channel, the X channel, and here is the Y channel. Now let's have a look at how that looks on our launchpad. The same pins on the launchpad are ADC in 16 and ADC in 19. So that's good luck, or maybe the Texas Instruments did it that way, but that means that we have two ADC channels for the inputs of our joystick. And with that info we can start configuring our microcontroller. The first thing we have to do is enable the ADC driver. Both pins are on ADC 1, so let's enable that one. And then we have to configure our ADC capture. We're not using events, so let's ignore this tab. We're going to the ADC group 1. We have a buffer of 16, although we only need 2. And we're going to take 12-bit values from the ADC converter. We enable both pin 16 and pin 19, and that is all we have to do in the configuration part. And the last thing I forgot to explain is that we have to enable the software triggering. We are going to sample the joysticks from within a timer in our software. You can also kick off ADC from hardware, but that's not what we're going to use in our program. I have created an RTOS task that will do the sampling at regular times. And what we have to do is start the conversion. We tell that we want to do the conversion of group 1, the group where our two pins are connected to. We wait for the conversion to finish, and then we get the data into our buffer for the ADC data and stop the conversion. So this is all we have to do, and at this point we have both the X and the Y axis. From then on we can just retrieve both values from that array of results. In my case, ADC data 0 contains the X-axis and ADC data 1 contains the Y-axis. And that's it, a very short example of how to collect two ADC samples at the same time.